Hello, my name is Mr. Castillo and welcome to my geometry class. Today I am covering the basic geometric vocabulary that you need for this class. So let's begin. So the way I have this set up is, over here I have the term, its formal definition, the notation, and the diagram. So let's start with this. Our picture looks like a dot. It's an undefined term in geometry, a specific location, it has no dimension, and is represented by a dot. We call that a point. In our notation for this, we simply say point P, because in the picture it's the letter P. Next up, so that's my 1 point. If I have 2 of these points and connect them, we have what we call a line. Right? It's an undefined term in geometry, a connected straight path. It has no thickness and it continues forever in both directions. So a few key things here. Key thing is that it continues forever in both directions. That is shown by these arrows. Those arrows are super important. In a bit, we will learn what it means if your line does not have arrows. So there's a few different ways we call this. First up, right here you have a letter L. Notice the L is not next to any point. Like A has a point here, B has a point here, but L does not. It doesn't have a point because it's referring to the line. Normally, this letter L, if it's referring to the whole line, is written either in italics, it's landed right there, or sometimes I will use cursive because it's easier for me to write cursive than to write italics. So it's in cursive, it's in L, so we simply call this line L. Another way we can call this is to use the 2 points on this diagram. So we can call this AB with a drawing of a line on top. Or we can switch the letters around. We can also call this BA with a line on top. Now, suppose I were to add a point there and call it C. Now we have 3 points. However, when we are naming lines, we still use just 2 points. Now, you can pick any 2 points here because all of them are on the same line. So I can also call this AC, or I can call this CB. Any 2 points work. So that's 2 points. If we have 3 points that's kind of scattered around, they're not in a straight line, we call this a plane. So a plane is another undefined term in geometry. It is a flat surface, it has no thickness, and it extends forever in all directions. Few key things. It's a flat surface and it extends forever in all directions. The notation for plane, notice up here we have an uppercase R, and R is not next to a point like X is, Y, and Z. R doesn't have a point. Just like with a line, this R refers to the whole plane. So in our notation, we can call this plane R, or we can use the 4 letters that make the 3 letters that make up that plane. We can call it plane XYZ, or we can switch the letters in any order. It doesn't matter what order they're in because all 3 are in the same plane. So we can also call this plane ZXY. Notice these first 3 terms are what we call the undefined terms in geometry. Reason they're undefined is because they are what geometry started with. Before these 3 points, we have no geometry. It's the very first thing that came in geometry. That's why they're called undefined. So geometry started with 1 point. If I have 2 of them, I can draw a line. And if I have 3 of them, I can make a plane. So now let's look at the next few parts. So right here, so we kind of have a line, but the difference is there's no arrows at the end. Because it doesn't have arrows, it means it stops. It stops at C and it stops at D. We call this a segment. A segment is a portion of a line consisting of two endpoints and all the points in between them. What it means by all the points in between them is here's C, here's D. So if I were to put the point, this point in between C and D, and that point, and that point, and that point. If I were to draw all those points in the middle of C and D, is you'd eventually come up with that solid line. Our notation for this is CD, or you can switch the letters around and say DC. Notice, segment, no arrows, line has arrows. Next up, now we have kind of like a line, but it has an arrow on one side only. We call this a ray. And notation for ray is PQ. A ray is a portion of a line that starts at one point, we call it the end point, and it continues forever in the other direction. For notation, notice I wrote PQ here. We cannot switch P and Q here because in your picture, the arrow is on the Q side. So when you are drawing your notation, writing your notation, Q has to be the second letter where the arrow is. Alright. Next up is we have two rays facing in the opposite direction. We have ray EG going to the right and ray EF going to the left. We call this opposite rays. Opposite rays, two rays that have a common endpoint and form a line. And just an FYI, in geometry, whenever we say line, we always mean one straight line. Opposite rays do not have a notation, so it's just opposite rays. Here's my definition, here's the picture. Next up, number 7 is talking about points A, B, and C. You will notice points A, B, and C are all on the same line. If your points are on the same line, we call them collinear. Points that lie on the same line. Another way I describe collinear is, can you draw one straight line that passes through all your points? If you can, then those are collinear points. Over here, number 8, now it's talking about point W, X, and Y. W, X, and Y. Notice X and Y are on the line, but W is not. This is what we call non-collinear. 3 or more points, not all of which lie on the same line. Not all of which lie on the same line. That's just a fancy way of saying at least one point is not on the line. And I wanted to point that out because in geometry you will notice a lot of the definitions and the English we use is very technical, it's very hard, it's very academic. And you will need to get used to reading that type of English because that's the type of English that you will normally see in this class. Alright, let's move on to the back. On the back, let's look at the picture. It says points C, over here, H, and D. C, H, and D are all on the same plane. They're all on the same flat surface. We call that coplanar. Points or lines that's all in the same plane. And coplanar does not have a notation. If we have coplanar, then we also have non-coplanar. That's looking over here. We have C, H, D, and E. Notice C, H, and D, they're all on the horizontal plane. However, E is on the vertical plane, so it's separate from the other three. That's what makes it non-coplanar. Next up, we have this picture of two lines that's not touching. We call those parallel lines. Lines in the same plane that do not intersect. And in our notation, we have X and Y. So we have line X is parallel to line Y. And again, I'm using cursive because lines are named using lowercase cursive or lowercase italics. Notice your lines have this weird arrow in the middle. That arrow right here means parallel. It's our way of showing on the picture that it's parallel. That's very important because here in geometry, we can show you something like this. I have one line go this way, and I have another line going this way. Looking at these two lines, you can tell, no, they don't look parallel. This line is obviously going to hit the other line if we stretch it. However, if I were to add these arrows in the middle, these arrows now tell me that yes, they are supposed to be parallel. In geometry, we don't go by what the picture looks like, we go by the symbols on the picture. And in this case, this symbol is telling us that those lines are supposed to be parallel. Next, we have a different kind of lines that also don't intersect. We call this skew lines. And skew lines don't have a notation. So here's the difference between parallel lines and skew lines. Parallel lines look like this. The two lines don't touch, and they're facing the same direction. They're both going this way, or they're both going this way, or they're kind of standing up, both going this way. Those are parallel lines. Skew lines are also lines that don't touch, but they're going in different directions. So these two lines aren't touching, but one line is flat on my paper, the other one is coming up. So they're facing different directions. That's what makes them skew lines. Right, next up, two segments that have the same length. Our math word for the same is congruent. So we call this congruent segments. And in our notation, we have segment PQ is congruent. Congruent is an equal sign with a squiggly line on top. Congruent to segment RS. And it's also written over here. Notice you have that line in the middle of your segments. I call those lines tick marks. Some teachers call it tally marks, some call it hash marks, some just call it lines. I call them tick marks. These tick marks right here, tick marks mean congruent. For example, I'll move over here. If I have this segment right here and this segment right here, clearly the second segment is shorter than the first segment. However, if I were to add tick marks in them, now I'm telling you, I don't care what the picture looks like. I'm telling you the segments are supposed to be congruent. They're supposed to be the same length. So just like with parallel up here, we go by the symbols on the pictures. Alright, next up, we have the point that divides the segment into two segments that have the same length. So it's the point that's sitting in the middle of the segment We know it's in the middle because the left side is exactly as long as the right side. We call that point in the middle the midpoint. And midpoint does not have a notation. But going back to the picture, again, if I were to draw this line, here's my segment, and my point is right here. Just looking at this picture, clearly that's not in the middle. However, if I add these tick marks and I tell you that the left side is supposed to be congruent to the right side, the left side is just as long as the right side, now that is a midpoint. I'm telling you it has to be a midpoint. Okay. Next up, we have a line, array, or a segment that divides a segment into two congruent segments. That's a lot of segments in there. So let's break this sentence down. Now we're talking about a line, array, or a segment. So it can be any of these three. From my picture, it's a line. So let's look at the line. It's a line that divides a segment. So it's a line that divides, that cuts a segment into two congruent segments. So a line that cuts a segment into two equal parts. So here's your line that cuts this segment into the two equal parts. We call this a segment bisector. And segment bisector does not have a notation. Just like with our midpoint, I can draw you this line and have my other line cut it over here. That right there is not a segment bisector because we can clearly see my line is more towards the left. But if I were to tell you that this part and this part are congruent, now I'm telling you that this has to be a segment bisector. Furthermore, this point in the middle has to be a midpoint. Right, last part, the set of all points in 3 dimensions. That's just our fancy way of saying that's the space we're working with. Right. So there you have all 16 vocabulary words that we start with in geometry. Some of the key things here I'd like to really stress on is the 3 undefined terms. We start with 1 point. 2 points make a line. If I have 3 points, I can make a plane. The point, line, plane. Another thing is the notation. Please pay close attention to all the notations. Notation is how we write these things in a sentence. For example, let me move over to the notation for parallel. This right here is a sentence. It says segment PQ, I'm sorry, that's congruent. So let's go with congruent. Segment PQ is congruent to segment RS. Or line X is parallel to line Y. Notation is how we write these terms when we're writing them in a sentence. It's to help us not actually write the whole word out. X is parallel to Y. Here, notations are shortcut. So please pay close attention to the notations. Our 3 undefined terms, super important. Then difference between collinear, non-collinear, coplanar, non-coplanar, and parallel and skew.